Okay, you guys, one last lesson for your statistics. This is called margin of error. The notes are already printed, so I'll highlight what I want you guys to copy down. And then we just have 4 examples, so it's a very simple lesson. So it says a population is a group of people or objects you want information about, correct? A sample is a subset of the population and can be used if it's too difficult, time-consuming, expensive to survey everyone. For example, let's say we want to survey high school students. Okay, we want to find something about high school students. Well, all over the world. How the heck could I ever survey every single high school student all over the world? It's too difficult, it's too expensive. So the population would be all the high school students, but a sample would be like, for example, hey, I'm going to sample Beverly Hills High School. Well, if you kind of think about that logically, if I sample Beverly Hills High School, that's not going to give me a good representation of everybody. So what we do is we calculate something called a margin of error. You know, this is going on with the coronavirus where they talk about, you know, the margin of error. I forget, I saw it on the news the other day and it was kind of interesting. So it's something used in real life. So a sample size, when conducting a survey, the larger sample size is more accurate than the sample we represent. So we have a margin of error, and then we kind of apply that to what the percent is, and I'll show you what I mean. Obviously, as the sample size increases, the margin of error decreases. Common sense. All right. So write this down. The margin of error, it gives a limit on how much the responses of the sample would differ. Here is your formula to calculate the margin of error. Plus or minus 1 divided by the square root of n, and n is the sample size. Okay, so write that down. Plus or minus. Don't forget the plus or minus. I've done it a few times, and that is definitely a common mistake. And then it's just 1 divided by that. Oh, and then maybe please do times 100%, because I'm going to want your answer as 100, as in percent. Otherwise, you're going to get a decimal. And I just wrote for example so you guys understand. If 40% of the population polled T, and the margin of error is the margin of error is plus or minus 4%, then what we say it's likely between 36 and 44% prefer T. So if we, chose, random people and 40% of those people were like, I like T. Well, we calculate the margin of error, and the margin of error is plus or minus 4. Okay, and then what we do is we take that margin of error and we do plus or minus, so we add it and we subtract it to the 40%, and then we say we have a better idea of maybe everybody that would like T. So here's how we do it. Very, very simple, you guys. So in a survey of 1,011 people, this is your N. 52% is your percent, because there's 2 questions I'm going to ask you. So right now I want that. For the margin of error, you're doing plus or minus 1 over that square root of n. So here we times 100. So plus or minus 1 over the square root of 1011. So if you guys got your calculator, please again don't forget, and let's just round all of these to the nearest tenth. We would have a margin of error of plus or minus 3.1%. Again, times this by 100. Okay, and that's your first answer. And then when I ask you for the interval, so just make sure you understand the difference. The margin of error is this answer. When I ask you for an interval, obviously an interval, you give me 2 numbers. What you would do is you would take the percent I gave you, and now you're using the margin of error, plus and minus 3.1%, and that will give me more of an exact percent of the people who use television. So add 3.1 minus 3.1, and here's what you guys get for your interval. 48.9 to about 55.1%. And that is the answer for part B. The second question I'll ask. Pretty simple. Okay, let's do it again. So we have in a survey of 1,535 people, that is your N. 48% prefer to go to the movies. Okay, what's the margin of error? The margin of error is that times 100. So we put this in our calculator. Enter, then times it by 100, and we get approximately plus or minus 2.6%. That's the margin of error. okay? Then when I ask you for the interval, again, the interval you're giving it as a percent, you're going to take the 48% who prefer it, and you're going to add and subtract the margin of error. Again, I'm hoping that this makes sense. I get 45.4% to about 50.6% of the people prefer to actually go to the movies. Okay? Again, hopefully that's pretty simple. All we're doing each time is using the margin of error formula, plus or minus 1 over the square root of n, and then taking the percent of things and adding it to whatever, or adding and subtracting to what I got for the margin of error. Okay, 2 other questions and you guys are done. The other kind of question I can do is I can work backwards. I know you guys hate this, but watch. It's a little bit more tricky, but bear with it. So it says a polling company conducts a poll for the U.S. presidential election. How many people? So you're looking in this case for N. Did the company survey if my margin of error was plus or minus 5? All right. Well, let's set this up. We know that plus or minus 1 over I don't know, correct, is going to give me about, well, 5%. But if you take a look up here, what did we get before we times it by 100? So if it's 5%, the number we got before we times it by 100 would be that number. Again, because this is what you guys get before you multiply it by 100. Once you set that up, now watch how we're going to solve it. Well, to solve it, to get rid of the squared, because you're trying to solve, in this case, for n, you want to get rid of the squared, right? So whatever we do to the top or the bottom goes together. I'm going to square that to become an n, and obviously whatever you do to the left, you have to do to the right, which is why it's an equation. Okay, 1 squared, 1. The square root of n squared is just n, equals 0.05 squared. If you put it in the calculator, it gives you 0.0025. Once you're here, now you're just going to cross multiply. It's pretty simple. So I get 0.0025 n equals 1. Final step, we divide. Final step, you divide. So in your calculator, 1 divided by 0.0025, and your answer is going to give you 400 people. That's it. You know, whenever you have a formula and what I can ask you for any of the variables, you just work backwards with it. So let's try one more and you guys are done. A polling company, here we go, conducts a poll. I'm just doing the same thing. How many people? So in this case, I want n, and I'm giving you it. So we set it up again, plus or minus 1 over the square root of I don't know. And again, it's 3%. So that means it became from 0.03. Okay, so we have 0.03. I have to do this one. So first thing we're going to do is we're going to square both sides. So we get 1 over n equals, let me just double check it, because if I do it without doing it, no. So it equals 0.00, I think 0, because if it's there, 0.3. 9. Because you're moving the decimal. Calculator's X is doing. Hold on 1 second. Oh, I want it normal. 0.03 squared. Whatever. So you're moving your calculator. If it says this, it wants you to move the decimal 4 to the left, which is why I think. Hold on 1 second. Pooper. 1, 2, 3, 4. Yikes, I did too many. There you go. Sorry, 0.009. Okay, now let's cross multiply. My fault. 0.0009 n equals 1. And now let's divide and let's see what we get. 1 divided by 0.0009. I get about 1,111. Obviously, it's decimal, so where is it closest to? That. Okay? So hopefully that was pretty simple for you guys, and it makes sense. That's margin of error. There's only 2 questions that you guys can be asked on it. Your homework tonight is a mix of margin of error as well as your normal distribution curves, so make sure you guys use your notes. Okay, you learned everything you need for statistics. Yay! Bye!